Hey everyone, welcome to another stream. I'm going to talk about something that could be very controversial depending on how you understand it, maybe where you learned it from, and how it applies. I'm listening to feedback from my own machine. Let me mute this tab. Sorry about that. I was using it for monitoring. I'm actually hearing feedback from another tab. All right, sorry about that. I hope that didn't affect what you guys were hearing. All right, so this can be very controversial, but I always say implement things according to number one, the business requirements of your application, and secondly, always apply your judgment. Not everything out there could apply to what you do. So I'm going to talk about clean architecture and how I want to apply it to this project. And yeah, that will come in a few minutes from now. But before that, I want to show you the problem I have at hand and how I want to approach it. And feel free to share your thoughts in the comments. I'm the type of person who learns from anybody and at any time. Now look at this. We have this function, okay, that is doing so many things. Okay, that is doing so many things. And my goal is to make sure that I organize the business roles in such a way that they are not trapped inside frameworks, databases, APIs, or libraries. And that is what clean architecture is all about. Organizing your code in such a way that it is not trapped inside any business tool like a framework, any database, any API, or any library. So the source code that has dependencies, okay, or our source code dependencies should point inward. So we're going to have, like, think of it as having layers, okay, an outer layer, an inner layer, then an innermost layer, okay. So you're going to see how all this is going to come about and how I'm going to approach it. But the goal is that our important logic should not depend on tools like Redis, like FastAPI, like SQL model, like Kafka. Those are some of the things that are being used in this project. But instead, it should be the opposite, okay? The tools like Redis, like our database, should be plugged into our logic, okay? So you're going to see that a lot. So I want to expand the screen and show you the problems I have with this code. Of course, this project has so many things, okay? But I'm going to use one function as an example, and that will be done to every other place in the code base. Now, on line 73, you see I have a path operation function, which defines a get route, okay? And if you look at this function, it is doing so many things. The first thing you can see is that it is handling the HTTP request. That is the first thing. And it goes on to format it, okay, by doing request.model_dump. That is the second thing. It goes on to build the catch. I think this build Redis key, Redis.catch, okay. This is already a problem. Our route is doing so many things. On top of that, it calls Amadeus. I think line 82, it says Amadeus flight service dot search flights get and passes in the request body. It is doing a lot. Then again, it goes on to write Redis. After writing Redis, it returns a response. After returning a response, we have error handling. This is the problem with this. And if you go to these individual functions which are being called, you find that the entire flow, okay, has a situation whereby our important logic depends on Redis. It depends on things like Kafka. If you go into the details of these functions, you see that it depends on Kafka, depends on FastAPI, depends on SQL model. An SQL model is a ORM I'm using. It depends on HTTP, this kind of stuff. So my goal is to make sure that in case I remove Redis, okay, I remove Redis, maybe I remove Kafka, I remove SQL model, the application continues to function in a correct way. You understand? So let's go ahead and fix this. But to fix this, I need to make a few definitions. All right, so to do that, I will maybe expand this and define to you a few things that comprise the clean architecture. So you're going to see me talk about a number of things as I refactor this project. But even then, there are key concepts that you need to know if it's the first time knowing about clean architecture. The first is called an entity. So in clean architecture, you have this term called an entity. An entity simply refers to an object, okay, in your system. That could be, for example, a booking. Okay, if you use this project as an example, we have a booking. So a booking is an object. We have a user is an object. We have a flight search is an object. We have things like a payment is an object. So think about an entity as a core business object. So any core business object in your application or in your code base is an entity. And this entity should not know about your framework, like maybe FastAPI or Express.js or Spring Boot or PHP or Laravel. It should not know about them. Okay. If you're using things like Redis, using things like maybe Amadeus in my case, or using any external technology, okay, it should not know about them. Then there's something called a use case when you're working with clean architecture. So a use case is an application action, an action that you're going to perform in your application. For example, now for this project, a use case could be searching flights or probably booking a flight or making a payment. That is what a use case could be. In your application could be something like registering a user or password reset or cancel booking or creating a booking. So a use case is simply an application flow. Think of it that way. And I've actually refactored this project to have the first use case. In fact, it's best I show you this step by step. So if I scroll, not scroll, but swipe away from the screen, I hope it will be visible. And I go to this other page and zoom in. You'll see the first use case. Okay. So look at this. Here now we have a use case. I've called it SearchFlights. SearchFlights, if you look at this code, I'm going to go through it line by line. It does not know about Redis, about Amadeus, about a database. It is simply performing the action of searching a flight. So here it gets a provider, a flight search provider, and a catch. This use case does not know whether the provider is Amadeus or Dafo or it is maybe Sabre or Travelport. All it wants is a flight search provider. It does not depend on any other kind of search provider. Then after that, we have a catch. Okay. It doesn't know whether you're using Redis, whether you're using maybe memcached, whether you're using maybe an in-memory cache or your hash map. It doesn't care. Okay. All it needs is a catch. So at this level, in the init method, we then instantiate. We say self.provider equals to provider, self.catch equals to catch. As simple as that. Then it performs the flow or the process of catching in this method or this instance method called execute, which takes a criteria. An equator is a mapping whose keys are strings and the values can be anything. Okay. And if you look at it, okay, it simply converts that mapping to a dictionary. Okay. Then it says the catch key will be equal to self._build catch key, which is a static method within this function, and which is just simply down here. Okay. What it does, it takes in a dictionary, okay, and joins the key value pairs of that dictionary, okay, with an underscore. As simple as that. So it says key value for every key and value in the dictionary. So dictionary.items, our dictionary is called data in this case, and data.items is simply a method that gives us key value pairs of a Python dictionary. So for every key and value, we combine them, okay, and separate them by a full colon into one string, but each of them is separated by an underscore. And that's how we get our catch key. But you look at this, okay? On the next line 39, it says self.catch.get. So it is not saying self.redis, self.memcached. It does not care about that. The goal is simply to catch. You get, that's the most important thing here. Simply catch. And then if there's a catch response, it returns that catch response. Then on line 43, it checks, okay, do we have a provider? Okay. Actually, that is wrong. It doesn't say do we have a provider. It simply says provider.search. So you see this provider here is anything. It could be any provider, okay, that you're using for searching. Okay, so provider.search, okay, then says self.catch.set. So this is the use case. It performs an application function or an application flow, which is for searching flights. But by searching for a flight, it does not know which external API is going to be used for searching the flight. It does not know which catch tool. Okay, by looking at this code, can you tell whether I'm using Redis? You cannot tell, and that is the advantage of using that clean architecture style. So I'll go back this other side and move on to something else. The other concept is what is called a port. So let me try to write well. Forgive me if my handwriting confuses you. We have a port. Now, what is a port? How does it apply? A port is simply an interface that says, what does the use case need? What does the use case need? And I'll go back and show you an example of a port. So if you go up here, we have our ports, okay? We have a flight search catch. We have a flight search provider, okay? They determine what the use case actually needs. So on line 31, you see that we were saying that SearchFlights requires a provider and a catch. But what are the definitions of this search flight provider, and what is the type, or what is composed of a flight search catch? So it simply says a flight search catch must have a get method and a set method. And a flight search provider must have a search method to help us to search. That is why down here you can say catch.get provider.search because of this. So these are the ports. Think of them as ports. Simply an interface that says that our use case needs the following. So in our case, our use case needs a flight search provider and a flight search catch. And each of their definitions or what they should have is given to us right here. So line 13, not 13, line 17, okay, and line 25 are ports, or simply interfaces that tell us what our search flights use case needs. I hope you get that. So we're going to refactor this this function here to look differently, and you're going to see it in a bit. And actually, in our day right now, where we're generating code using AI, it's very important to understand these things so that you know what to change and maybe how to prompt better and how to know what is good or bad for your code base. Cool. Next, I need to talk about another concept, which is called an adapter. Okay, maybe I can go through all of them and then share with you in one go. We have what is called an adapter. So an adapter is what will help us connect an outside tool like a database, Amadeus, Redis, okay, or therefore to our application port. And I'm going to show you in a minute. Then we have what is called the presentation. The presentation is simply how the outside world interacts with the application. Hope I can write this well. So presentation is simply how the outside world interacts with our app. Then there's what is called infrastructure. And I'm going to show you this in a minute. So with infrastructure, this now refers to all the external tools, okay? Like Redis, like the database, Kafka, okay? And think about infrastructure as, look at what I've typed. Guys, I think I'm high or something. What did I eat this morning? Okay, I'm high on something. This is called infrastructure, not infrastruction. I'm trying to invert English on the go in a live stream. Please don't clip this. Okay, I know many of you are now clipping this and are going to put it in your shorts, but it's okay. So infrastructure simply refers to everything which is external or technical, and we can easily replace them for something else. Yeah, so let's now move to the change. Okay, you're going to see the change from this to something much better. So I will go to this other function. Okay, so the use case, I think this use case called SearchFlights is being stored in a directory called application. Okay, the infrastructure, I'm storing it in something called infrastructure. Why am I thinking too hard? Okay, and yeah, the routers remains routers. So everything is going to change, but slightly, and you're going to see how it changes. So I've shown in the application folder, we have the use case and the ports. I'm thinking of putting the ports separately in case they become too many. So we have the use case, in this case for searching for flights, and the ports, which simply tell us what the use case needs. Then we have when we go to here, infrastructure, flights, Amadeus search gateway, you'll find the adapter, okay, which will help us to connect the outside tool, which is Amadeus, to our port. So in this case, you see we're only saying self.flight service equals to flight service, okay, and it's of type flight service protocol. This protocol was actually defined in an earlier stream, okay, can't remember when, but way back. But if I go to it, you'll simply see an interface that defines that we have a protocol or a class that should have this number of methods. Okay, as simple as that. I'm sure many of you who have been following know about this. Then also it defines the search function, which says return self.flight service.search flights. As simple as that. Then something else that we need to understand is how all this now picks up and is put together. So how do you put this together? Look at the new flight search function. Inside here, it simply says return search flights use case dot execute, okay, and we pass to it the request body. As simple as that. So it simply calls the use case for searching flights and does error handling. Only that. So compare this to what we had previously. Look at this. Okay, they are way different. If you compare this, okay, to this, our router is now doing two things only: calling the use case and handling the errors. Nothing else. We've removed Redis, we've removed every other thing. Then when we go up here on line 88, you see that we have a dependency called get SearchFlights use case. It is simply a helper method which helps me to get that use case called SearchFlights. And if we go up, you'll see that it is simply a Python function which returns SearchFlights. And then using dependency injection, we inject the provider and the cache. Do you see that? Provider and the cache. And for our case, the cache could be anything, okay? But right now I'm keeping it simple and saying that the cache is a Redis cache. And the provider, we're now using our adapter to help us connect this Amadeus tool or this flight search service to our port. So this is how everything, let me go to it to show you a definition. Okay, using it says return self.flightservice.search, and we pass to it the Amadeus flight service. As simple as that. So this provider can be anything. That's the goal I'm trying to show you here. This can be anything. Okay, it can be anything. And our use case does not care whether the provider is none or whatever. Okay, get. So I want to understand that this could be anything. They just have to implement the methods that the ports say they should have. All right. I think that's what I have for this. So I'm going to make sure I refactor every other function. Okay. And I will then push this to GitHub and mirror it to the other repo so that you can see, contribute, fork, make changes, adapt it to your own way. Because I see many of you have forked this project and I'm sure you're owning it and building it in your own way. So tell me if you've understood this, if it makes sense, if it is simple, whether it's just more code or it's difficult, simple. But I think for me, it makes it much easier and it makes testing even much easier. Now I can test this function much easier. I can test the use case alone, separately, without having to require maybe Amadeus credentials. It would be easy to do so. Okay, but what I like is how clean this use case is. That you don't know the cache you're using, you don't know the provider you're using, but the actual flow is defined. So I appreciate you joining today's live stream, and I'll see you in the next live stream or the next video. Bye for now.